Greetings everyone, we're back, and I'd like to point out that I've created an initial repo under GitHub, Groxio Learning, Tetris video. We're also, when we add Phoenix LiveView, we'll have a Tetris UI video just for this video series. And what we'll try to do is for each one of the videos, we'll be working in a different branch. So the branch for this one, you can see I have everything set up to be part 2. So we actually have the Tetris that we initially created that maps onto the repo, and we're looking at part 2 right now. So let's go ahead and open that up. Okay, so what we have is a successful random creation of our individual pieces, and so we actually have an API that I like quite a lot, actually, that allows us to create a new name, a new brick with some kind of a structure that's predictable for our tests, and then we can also create a random one that our game will actually use. Now, it'd be nice to go ahead and run a test for this, and so this won't be too hard. So let's go to brick test, and let's say test creates a new random brick. And what I'm going to do is say expected, or the actual. So the actual thing that we're creating is a new random, and then I'm going to make a couple of assertions against the actual. So if I was just comparing one thing, one pattern I like to use is say actual is this, expected is this, and then I can compare the actual to expected. But in this case, I want to look at the individual pieces of the actual. So I'm going to say assert actual.name is in, so that's going to be in what? The I, L, Z, T, and what was the last one? Uh-oh, yep. And so let's see if that much runs so far. Mix test. Looks good. So let's go ahead and make another couple of assertions. You probably hear the speedboat going by outside. So this is a rotation is in, and these are just numbers, so 0, 90, 270. Oh, I need a 180. Okay, and assert dot reflection is in true, false. I could have also checked the class and compared to the Boolean type, but I think that this kind of keeps a nice symmetry in the test, so we'll do it that way. Looks like that is working fine, so git commit, and I'm writing the tests for actual, or for new random, and that's good. Okay, so I'd like to point out a couple of the concepts that we're going to be using as we manipulate the brick. Now, one of the things that you might have noticed is that Elixir is what's called a functional language. And that means that there are pieces of this application that we'd like to keep as pure as possible, meaning that when I call a function on something, it behaves the same exact way every time. So, for example, after I create an individual brick, I'm not going to try to manipulate everything at once. I'm going to try to have some predictable changes that I can make to the brick. So, for example, I'll probably have some behaviors for up. This is going to take a brick, and that'll eventually return a brick. So I'll do that implementation later. And since this is going to be a full implementation. It's probably better not to have this one line. But I'm going to have a behavior for up, and I can also move it down. And I can also spin this thing, spin it 90 degrees. Or maybe I should be able to rotate brick and some degrees. And so these are special types of functions. They're going to take a brick and they're going to return some type of a brick. Every single one of these will return some type of a brick. And since they take and return the same thing, we're going to call them reducers. And that's almost a magical type of function, because it's going to have some special properties that make it easy to build special compositions. It's going to work better with LiveView. It's going to work better in our test. And it's also going to allow us to build with compositions using the pipes that you saw earlier, like this one right here. So we're going to need a syntax that takes a brick and changes one thing. And that's called the map update syntax. So I'm going to open up IEX-S mix, and I'm going to alias, so Tetris.brick. And so now I can say, I can get a brick to work with. Or new random. So now I have a brick. And it'd be nice to be able to take this thing and change one thing. Oh, I've noticed that this actually is a map and what we actually want it to be. It's not the same thing. So you can see this is actually a struct because it has this module name here. And I can go ahead and add this module name easily to the new random right here. Like this. This means go ahead and add the name of the module. Sure, I could type Tetris brick, but then if I rename that, it wouldn't work as cleanly. So I'd like to think of this as the module for whatever file this is in. So let's go ahead and create a random, or let's go ahead and implement one of these. So for example, maybe what I'd like to do is and this is going to take some type of point and it's going to move it down. So this will move point down somehow. And so for the brick, what I'd like to be able to do is take the let's recompile and let's make sure that we get this the correct way. So brick.new, yeah, so now we have a Tetris brick that we're going to use. And so I'm going to use something called the map update syntax. And that means I'm going to type the characters for an empty map. Then I'm going to say, let's go ahead and use B. And what this means is I want you to create a new map, and I want you to use all the properties in the old map except the ones that I specify here. So here I might have a location, and I might change this to 41, right? And this is going to allow me to create a new brick that's moved, where everything else is the same, but I've moved down one. So yes, so I've moved down. So let's create some functions to do this instead. So the first thing that I need to do is put this in, right? So the next thing that I need to do is I need to get the point somehow other than hard coding it. So I'm going to build a function, the point down. And I'm going to take brick. I'm going to take the location out of that, which is the initial point, which is kind of nice because now I can use that point in here, and I can use Elixir's trick called deconstruction. So a point has an X and a Y, and if I go ahead and type the same structure here, I can use that X and the Y in my formula, and let's see what it looks like. So in this case, the X and the Y, well, X stays the same, doesn't it? But Y is increased by 1. So I'm going to say X comma Y plus 1, and now I've moved down. Now I can recompile. Oh, I broke something. Undefined function B, yes. So rather than B, this is a brick. So now I'll recompile again. It likes me. So brick and degrees are unused. These are all these variables that we're not using yet. That's okay, we'll use them pretty soon. But let's go ahead and see if things are working. So now I'm going to take the brick and the location, or I'm going to take my brick, and I'm going to pipe that to brick.move down. Move down is undefined or private. Oh, it's brick.down, isn't it? Brick.down. Yes, and so it moved me down, but what it did was create a copy of the old brick with these new attributes. So if I look at B, B is exactly the same. So now I can take so if I look at B, it's unchanged. But if I wanted to move it down twice, I can move it down twice, and lo and behold, it keeps everything the same, but moves me down twice. So let's go ahead and flesh out the implementation of the up. That's going to look very much the same, isn't it? So that's up, but I'm going to call point up. And for down, so actually I don't need it up, I need a left and I need a right. And I'm going to copy this. This is right. And this is point right. That's great. So I'm going to take this implementation and I'm going to share it a couple of times in almost every detail. But left, no, I don't need that. I need the point down, don't I? So I'm going to take this, and then I can share this in most details. So this is a left, and this is a right. And these don't need to move Y at all. They need to move X. And left is going to subtract 1, and right is going to add 1. And let's see if this works. Okay, we're slowing down on our compile warnings, and I bet that I could take this and also, so brick.left, and so as you can see, this moved me left 1, and so brick.right moves me right 1, brick.left moves me right back to where I started. So I did a left and a right. So that's great. So now all I have to do is work on the one where I spin 90 degrees. So let's look at that one now. So spin 90. So I'm going to take, I am going to take the rotation or the brick, and I'm going to use the same map update syntax. And rather than change the location, I'm going to change the rotation. And rather than point down, I'm going to call spin degrees. And I'm going to pass that brick dot rotation. So now I need to, well, let's say we don't need the rotate yet. Let's just say that we need the spin. Maybe we'll call this one rotate. Okay, that looks good to me. Def rotate. So if this is a 270, I'm going to return a 0, right? Because it'll wrap back around to 0. If it's anything else, so I'll just say degrees plus 90. So now I've rotated. So now looks like all my compilers are gone, and we can actually spin this. Okay, let's see. Key D not found. Okay, so that means so my spin 90 is broken. Let's see what's wrong here. So my spin brick.d, which is, yeah, so degrees. Yeah, so I basically didn't use my editor in the right way. So I tried to look for, hope I didn't save this. There we go. There we go. Oh, key degrees. This is rotation. Okay. Okay, it looks like we've spun that 90, and if I do spin 90, that'll bring me back around to 0. So that looks pretty good. So we can do a couple of tests if we would like. Let's write a few of those. So all we need are tests for should move left, should move right, should move down, and should spin 90. But I'm going to try a trick here. I'm going to go ahead and create a default brick, and I'm going to actually conflate the meaning of my test, but I'm going to do it for I'm going to do a bad thing for a good reason. Should manipulate with, okay, and I'm going to say actual is equal to, and I'm going to say new brick. I start with the new brick, and I'm going to test that by move left, or I'm sorry, left, right, and then I'm going to say down, and then I'm going to say spin 90, and that should be pretty good. Now I can say, I can look at the individual properties of this brick. Actual location, is, and what will that be? So I'm starting at 40, 0. So I'm going down, so it's going to be 41. I'm going right, right, left. So it should be 41, 1. And the actual rotation, since I start at 0 and I spin 90, let's add another spin 90 just for grins. So that should be at 180. So here what I'm trying to show is that our tests can have some pretty sophisticated behaviors, whether they make sense or not, actually. So, but this kind of shows the power of building our code with reducers, something that takes a brick and returns a brick. So let's run our test. Here we go. That's it. So it looks like that is working. Movement and tests, but I haven't added my files yet, so I'll go ahead and do that there. Okay. You push origin. I want to track this. Origin part 2. Oh, but there's a hyphen in that. That's going to give me some grief, isn't it? Okay, well, we'll go ahead and chop this out. So that's what we have for the second piece of our Tetris. So that's what we have for the second full coding module of our Tetris. And the next time we'll turn around and pick up actually rendering some of the points in our Tetris block. That'll be a lot of fun. You won't want to miss it.